In the last section, we'll speak about the endpoint security. Again, just fundamental overview of what would you ideally want to do on the endpoints, based on the type of the endpoint, how to better secure it, and how to secure the access to the network. So pretty much, if you want to provide security in your network, it means that pretty much all endpoints need to be secured. And of course, I'm not speaking about server security, that's not a topic, but about whatever user devices you connect to the network, like laptops, desktops, mobile phones, tablets, printers, IP phones, video conference systems. Everything needs to be secured, because the weakest link dictates the overall security strength. Now, endpoint can be divided into three categories. Like desktops, laptop servers, you're gonna perform some kind of security. Let's say you're gonna put some kind of security functions in there. Mobile devices, smartphones, tablets, which means other kind of security functionalities. And non-user devices, which means printers, cameras, IP phones, video conference systems, whatever else is connected to the network. And of course, in the world of IoT now, it's going to be a lot of non-user devices connected to the network. IoT meaning Internet of Things. Now, let's take it one by one. So when I speak about the desktops, then a bit about mobile and non-user devices as well, but mostly about desktops and laptops, because pretty much those are the dominant, let's say, devices in the network. And mostly a lot of attacks are happening, of course, in that area, because those are constantly used user devices. They are complex operating systems with, of course, a lot of flaws, a lot of vulnerabilities, which can be exploited. So traditionally speaking, endpoint security was achieved through a personal firewall, a antivirus, an anti-spyware, and non-privileged user access, meaning don't grant those users privileged access to the computer, because to perform their day-to-day job, they don't need that. They need just a basic user account. So one of the, let's say, reasons for offering the users non-privileged user access is that, for example, imagine that if the user downloads some malware from the internet, it's different types of malware. So if it's a type of malware which needs to install something on a computer or modify the registry or whatever, then a regular user account doesn't have the authorization to perform that. So it means that the downloaded malware is inoffensive, can do nothing, because it's going to run in the user's context. And if the user is a regular user, it doesn't have rights to modify any system files or registry files. Well, if you grant the user admin access, that clearly they can do whatever on their machine, which means also whatever they download or get from the internet, which is malicious, can do everything on a machine. So let's take it one by one. Personal firewall, which is nothing else but a layer 3, layer 4 stateful firewall. So it is going to inspect endpoint initiated traffic and automatically allow the return traffic. And it's going to control, of course, what traffic can be initiated towards the endpoint. Like you would want, of course, what traffic is being initiated by the user, you would want the firewall to allow the traffic back in. But then, because if that's a regular user system, doesn't offer any kind of services, like it's not a server, then you may want nobody to be able to send traffic to that endpoint at all to secure it, right? And of course, modern operating systems, all of them have built-in firewall, which of course optionally it can be replaced by a third-party software if you so choose to, for whatever reasons. Maybe it has a third-party firewall may have better capabilities, stronger capabilities, depending what you want to achieve. But usually nowadays the personal firewall, which is built in, is good enough. Most companies rely on that firewall in general. Windows has a predefined set of firewall rules, for example, based on the network type. So when you connect to a new network, Windows is going to ask you, is that a work network, a home network, or public network? And based on the network type you choose, is gonna make the firewall to be stronger or less stronger. Like if you tell Windows it's a public network, then it's gonna make the firewall policy to be stronger, more secure, because you're exposed to more danger when you're in a public network as opposed to a work network or at home. So based on what you're selecting there, is gonna head as head a set of predefined firewall rules which is gonna apply on that computer. Antivirus, as the name says, is going to protect against viruses, but of course viruses have different forms: viruses, worms, trojans, malware. So pretty much a lot of types, a lot of malicious code is going to fall down under the category of antivirus in there. And those engines, the antivirus engines, detect malicious code based on either signatures, so that's going to be for known malicious traffic, or based on heuristic and behavior analysis, which is used in order to detect unknown malicious traffic or malicious code. Now, of course, depending on the vendor, they chose to implement that heuristics and behavioral analysis in different ways. So, for example, some vendors are going to simulate that code in a virtual space to analyze the results. Like, for example, if your antivirus engine does this, performs behavioral analysis this way, it means that as you download something from the internet, then before it's gonna let that file to be stored on the computer's disk, it's gonna simulate that code in a virtual space to see, okay, if I would let this file be downloaded on the hard disk, what would happen? And if, for example, you can imagine that if you download a PDF file from the internet, and when they execute that file in the virtual space, the detective is going to try to change some registries on the computer, then that's clearly malware, because how a PDF file should never like affect the registries, for example, right? So it's a way of simulation, like a way of sandboxing, a pseudo way of sandboxing, to see what would happen if that file would actually be stored on the disk. What would it do? Or other vendors choose to decompile the code and just analyze the results. So they do some kind of mathematical analysis to see, okay, let's see what the code is behind the scenes, and is that code, malicious or not. So that means they don't inspect the result. They just inspect the content, the code itself, to see if it's malicious or not. Anti-spyware. So spyware is going to be malicious software aimed to spy on user or on the device. As the name states, it's spyware. And anti-spyware is going to protect endpoints against malicious software in real time, of course. So a couple of types of spyware is going to be system monitors like keyloggers, which means you download some kind of piece of software which logs everything you type on your keyboard in order to leak your usernames and passwords, for example. Or Trojan, which could be used to intercept computer communication. Like, for example, you download a Trojan of type spyware, which means whatever traffic you do from that computer is going to copy that traffic and send it out to somebody else, so they know everything you do on your computer. So it's a type of spying. Or adware, which means advertisements commonly seen in browsers, of course. And tracking cookies, which means the server which you connect to, the web server which you connect to, is gonna use tracking cookies, which means it's gonna track all of your web activity. Or actually, you may get a spyware which likewise tracks all of your web activity. Anti-spyware is solely based on signatures. And of course, as you can see, even in spyware we have Trojans and we have keyloggers, for example, which is pretty much like a malware. Or the Trojan, it's of course a kind of malware, but because this malware is actually aimed to spy, falls under the category of spyware. So antivirus, anti-spyware, and of course then we have malware, which malware is on the rise. And the problem is that today's new malware is developed at a very fast rate, which means it takes too long for signatures to be released and deployed to end systems. Because you can imagine that the antivirus or the anti-malware vendor has to first detect that's malware, then write the signature for the malware, then publish the signature. Then, for example, your centralized antivirus policy system in your network has to download the new signatures. Then it has to also push over to all endpoints all new signatures. And some endpoints are not connected to the network, are going to be connected to the network maybe 1 month later, which means in that month they are vulnerable. And even though that's so, first of all, it takes too long for signatures to be released and deployed to end systems. And second of all, and most importantly, actually, with a very fast rate of new malware showing up, they stay like hundreds or thousands of new malware shows up on a daily basis. It is nearly impossible to have a huge team of engineers which they do nothing else but release signatures in proper time to offer some kind of protection to their customers. Because it doesn't make sense that once a new malware with a very high risk was seen, if you deploy a signature like 1 week later, it's pretty much useless right at that point. So because the malware is moving very fast, it changes rapidly, it adapts, and a lot of new malware is being deployed, it becomes close to impossible to actually have humans detect that malware and write code and then publish it for the systems to be updated. And also new malware is becoming stealth more and more, which means stealth means that as malware shows up, gets downloaded on the endpoint, it may keep quiet, silent for hours, weeks, or months, and only afterwards start doing something. And which means that a regular antivirus or anti-spyware cannot keep up with today's malware type pretty much. So they're becoming less and less efficient, which means ideally on the endpoints we need something more intelligent, a better intelligent endpoint security capability, so that we can actually keep up and detect, prevent, and stop new malware in time from being, let's say, from infecting our endpoints. We're going to see in a couple, of course, what a CISCO solution. It's going to be a module in AnyConnect. So for that reason, we're going to speak about the AnyConnect client of CISCO, which initially started as an IPsec SSL VPN client, IPsec only with IPv2, but today is a modular client with added capabilities. So you can choose to when you install AnyConnect, you can choose to install additional modules as well. So it has a module which acts like a .NET supplicant. It has the ASA posture module, IS posture module, AMP enabler, and cloud web security. I'm going to take each of them and speak briefly about some of them we spoke to already, like the cloud web security module. So the .NET supplicant is nothing else but, so instead of using the built-in operating system supplicant, you may choose to install AnyConnect as a supplicant. So in that case, the .NET authentication process on the system is going to be controlled by AnyConnect, not by the built-in Windows or Mac supplicant, Windows or Mac supplicant in there. And of course, except the fact that it's a different supplicant, of course it adds a lot of other capabilities. It's a lot of, let's say, additional capabilities it supports, but some of them would be that it supports EAP-FAST as the authentication protocol. It supports EAP chaining, which means to authenticate at the same time both the user and the machine. And also it can control the computer, the end system, to allow a single NIC card to be active on the endpoint at the same time. Because the user may have like one Wi-Fi connection active, one wire connection active, and maybe one WAN connection active, like a 3G or 4G. So it's really dangerous to have all of them active at the same time, because the computer at that point could become a relay, and it's connected to too many networks at the same time. Some of them less trusted, like the internet, the 3G connection. Some of them more trusted, like the inside network. So that's clearly, it becomes it becomes a vector attack, because the PC has at the same time multiple multiple connections active. And AnyConnect can prevent that, can allow only a single NIC to be active at the same time on the endpoint. The ASA posture module is useful nowadays only if you don't have ICE in your network, and only for VPN connections terminated on the ASA. What this means is that when you're gonna terminate a VPN tunnel on the ASA using, of course, Cisco's AnyConnect client, if you have the posture module installed, the ASA is gonna scan the end system for the OS type and patch version, like Windows version, patch version, any kind of upgrades available in there. It's going to scan the system to see if it has a personal firewall active or installed, antivirus, anti-spyware, so a lot of those things. And based on the configured policy that you do on the SA, for example, you may configure the SA to state something like, if any VPN connection comes in, and when I scan the system, I realize that the personal firewall is not turned on, you may tell the SA to drop the VPN connection, disallow it. Or you may tell the SA to give a different authorization to that user if he doesn't have an antivirus system, because it could be an infected endpoint. So based on the result of that inspections, you can configure one of them or all of them, and based on the configured policy on the SA, then the VPN session can be established or not. And of course also the ASA, if you have that ASA posture module installed on the client, it can actually force the personal firewall to be started, or antivirus or anti-spyware to be started, because maybe those services are being stopped accidentally by the user or on purpose by any malware installed on the system. You can also force personal firewall rules or antivirus and anti-spyware updates. So let me fix that up in there because there's a typo. So it can also force antivirus updates to happen. So the SA can say something, okay, so you don't have the antivirus service started. If you want to connect, I'm gonna start the antivirus service for you. Then it's gonna realize that the antivirus is not updated, so it's gonna force the antivirus to get updated, and only afterwards it's gonna let the VPN connection to be successfully established. The AnyConnect ICE posture module, which is the old NAC agent, it's preferred against the ASA posture, as it is going to do pretty much the same thing, posturing or assessing the health of the end system. But the main advantage is that it doesn't depend upon the connection type. So the AnyConnect posture module, which is the old NAC agent, allows you to do those inspections on the client and do remediation on the client regardless of the connection type of that user. If the user is connected via wired, via wireless, or via VPN. So what happens is that you configure on ICE endpoint health compliance policies like OS type, patch version, firewall, antivirus, anti-spyware. A lot of other things are available as well. And when the user connects to the network, the AnyConnect ICE posture module evaluates, so scans the computer and evaluates if it's compliant with ICE defined rules. And it's going to also, of course, tell ICE if it's compliant, if the endpoint is compliant or not. And based on the result, ICE is going to grant specific network access to the user or no access at all. Like for example, if it's non-compliant endpoint, the ICE can choose to quarantine the endpoint for remediation, to be like for somebody to come in there and fix whatever problems have been discovered, because it's considered to be either an infected endpoint or an endpoint which could be a threat vector in the network because it doesn't have the antivirus installed, for example. And then the intelligence which I was speaking about, the AnyConnect AMP enabler. So the advanced malware protection is going to be that additional intelligence which is going to allow the endpoint. So if you install that module on the endpoint, is going to allow the AMP is going to do advanced malware protection, which means it's going to be able to detect unknown malware. And of course, it's going to be able to detect also new type of malware, even malware which is being stealth. So AMP provides protection to the full attack continuum, likewise before, during, and after. And AMP automatically detects and blocks known and emerging threats, which means unknown new attacks in real time, using a lot of, let's say, built-in features, like for example IP reputation and custom IP blacklists. So if the traffic comes in from a specific well-known malicious source from the internet, AMP is going to drop that packet. So there's no need even to inspect the packet, because if it comes from a well-known malicious bad reputation source from the internet, 100% chances or close to are that that's going to be also malicious content. It also have one-to-one signature matching. It has some signatures. It also does fuzzy fingerprinting, machine learning, and also uses auto detection modules. What that means, so fuzzy fingerprinting and machine learning and auto detection methods are used to detect unknown and emerging new malware. So how that works is that unknown or stealth malware is detected through continuous analysis. So AMP is going to continually monitor, like watch, analyze, and record any file activity regardless of the file's disposition. So what that means that, let's say initially a file was downloaded on the computer and AMP stated that the let's say the status of that file is not malicious, so it's a good content. But then because AMP has learned the computer behavior, what the computer does on a regular basis, and because AMP constantly monitors once a file has been downloaded, it tracks the whole history of everything which happens on the endpoint. So if AMP is going to take that a PDF file was downloaded today, and for example 25 days later that PDF file starts stopping some computer processes, or stop making some registry changes, or start sending some command and control like keep alive messages out on the internet to their command and control center, clearly AMP is going to be able to detect that, because as I stated, it constantly watches everything which happens on a computer, and AMP is going to say something like, how come a PDF file which I downloaded 25 days ago, it can stop the antivirus process, or it can send a keep alive out on the internet, or it can change the registries. Clearly that's a new way, that's a new type of malware which is stealth. So AMP is going to be able to catch that. Offers file trajectory and device trajectory, which means it's going to tell you exactly what is the trajectory of the file, from where did the file got downloaded, using what protocol, on which system, which user was connected, and then also to which other systems that file has been also has been also replicated, which means what other systems have been infected. So that's also that's the file trajectory. And device trajectory is going to show you what the file did on the host. Like exactly what I told you, it's going to show that today the file was downloaded, it kept silent, and 25 days later it started doing something weird. So it's going to be able to give you all of that information, so that it's going to, in the end, it's going to detect that's a kind of malware. So it's going to at that point stop or block the attack, or of course because it's too late, the endpoint is already infected. Then AMP is going to alert you so that you can take further action. Or of course AMP can be integrated with ICE, which means AMP is going to tell ICE that that user's endpoint is infected, and ICE can change authorization, so quarantine the endpoint for remediation purposes. AMP on endpoint is available for Windows, Mac, and Android systems, so not for Linux and not for iOS systems so far. And AMP policies and updates are managed through Firepower Management Center. Now, of course, AMP has a set of has a set of signatures, does machine learning, machine behavior analysis, but pretty much the intelligence of AMP is not on premises, but it's in cloud. So we spoke before about web security appliance, email security appliance, NGIPS, next generation firewall, all of them having that AMP capability, and also now AMP on the endpoints. But how does AMP, how is AMP actually able to detect a lot of new malware? It's through a centralized intelligence, which is CISCO Talos. CISCO Talos is nothing else but a huge, let's say, a very big object, a big thing, which is big data analytics for threat defense scope. It's also known under the term of CISCO Collective Security Intelligence Cloud. So Talos is first of all a huge team of engineers, qualified engineers, which constantly monitor what happens on the internet, constantly monitor the alerts they see from the internet, from different resources, from different systems of Cisco deployed to customers, and they constantly readapt that big smart intelligence engine Talos to be able to secure Cisco's customers. So it's a big team of qualified people, and also Talos stores the detection and analytics engines, stores the detection signatures, and also that it's going to be the big thing that's going to test the files with unknown disposition. So when AMP is going to see a file being downloaded, so either AMP on web appliance, on email appliance, on the firewall, or on the endpoint, sees a file being downloaded, If it does, if that file is not no malware, then it's gonna upload it to the cloud. So the cloud is gonna be able to detect based on its intelligence if this is clearly malware but was unknown before, through advanced sandboxing techniques. And Talos also maintains the official rule sets of snore.org, which is still, and it was the largest installed base of IPS systems in the internet. Clam antivirus, sender-based work, which was the Ironport database intelligence, and SpamCop. So Talos maintains all of those rule sets. And also Talos gathers data from ThreadGrid, from all of the AMP endpoints, and from OpenDNS, from a lot of resources, so that it's going to be able to better and faster detect new malware flowing through Cisco customer security devices. Now, from the mobile device security point of view, the MDM platform is highly recommended because it allows you to configure and enforce health and security compliance policies for mobile devices, and especially nowadays when malware on the mobile devices, it's very big. It's like the next big thing. Malware on the mobile devices it's way bigger, and it's a lot more malware being developed for mobile than for regular endpoints. So you would want to clearly secure the mobile devices as much as you can. And for example, one fundamental rule which you should always make sure it is in place is that not to allow jailbreak devices in the network, because if a mobile device is jailbreaked, then the built-in security features of the operating systems are gone at that point, which clearly it's a big attack vector at that point in your network. To MDM, you can also restrict user access to specific device functions. You may restrict the users from using the camera in the office, for example, not to leak data, or to not use specific applications, for example, which are known to be malware. It also containerizes sensitive data. So it's going to do some kind of, it's going to somehow split the device into a business portion and a user portion, and whatever is business related, whatever has to do with the company, like the email account data, any kind of files, any kind of shares, are going to be containerized in a container which is encrypted and accessible only via authentication, like via the PIN code, and there is no application on the endpoint which is allowed to read data from that container to avoid data from leaking or from being infected. And also we have AnyConnect for mobile offers, which supports per op VPN, which is a very interesting feature supported by Cisco AnyConnect, which what that means is that once you allow a VPN session to be established from a mobile endpoint, you may want to control which applications from that endpoint can send traffic in the VPN tunnel. And that's clearly a very good way to further provide some further security, because you never know what applications the user has on the mobile device, and you never know which of them contain malware. So as as long as the user connects, you're no longer do split tunneling like network level, but you do split tunneling application level. So you're gonna configure the AnyConnect client so that only, for example, the email client and the one browser can actually send data to the VPN tunnel, but not all applications from the mobile should be able to send data to the VPN tunnel. And of course, on the non-user devices, the challenge in there is that those devices like printers, not IP phones, but like printers, cameras, video conference systems have been designed with functionality in mind and not with security, which means their operating systems are very vulnerable, have a lot of flaws and vulnerabilities which can be easily exploited by the attackers. And if the attackers get access to your printers or to your phones or to your cameras, it means they are in the network, and from there they can do a lot of damage. Because one of the challenges nowadays for the attackers is to get access to a system in the network, and of course remain stealth, not to be discovered. So ensure that only authorized users can access these devices to begin with. those non-user devices. So control who can access those devices. Like you should allow internet access to your printer or to your video conference system. Of course, to the video conference you may have to allow it if it's publicly available. But to your printers, no need for that. To your IP cameras, no need for that. And also make sure that you authenticate those devices via map and profiling, and you authorize network access, which means you control what traffic those devices can send in the network. Like there is no way why a printer should send internet traffic in the internet. A printer is used in your company so that you give to the printer actions to print. The printer doesn't go in the internet to send emails or to download FTP files from the internet.